All right, folks, I got cut off in that last video. So going back to number 15, this is 10 to the log of 6. And because there was no subscript written there, I can assume that this is common log of 6 or log base 10. So I wrote in that subscript or the base of 10, and that just makes that canceling out of the 10, with the log base 10 a little bit easier to see. And that leaves me with just that 6. On number 16, it looks like we're kind of stuck here. It doesn't appear to be anything that we can simplify, but this goes into the rewriting strategy that we kind of use to solve those exponential equations. So currently, I can't cross off this base with the answer part's base, but if I rewrite 9 as 3 squared, then log base 3 of 3, that cancels, and we are left with just 2x at ground level. For number 17, this is an important property, which we're going to get into a little bit more once we start solving. You may have seen this before in Algebra 2, though I know not all of the teachers cover it. Base E and natural log are actually inverse functions and operations. So just like squaring and square rooting are opposite operations, we can square root to get rid of a squared. We can actually E both sides or natural log both sides to get rid of the opposite operation. So we'll get into this a little bit more once we start solving next week. So looking at this one, if I have e to the natural log is the same as log base e. So we have e raised to the power of log base e. So those cancel each other out. So what I am left with is the 3x. Same with on number 18. If I have natural log of e, that is the same as log base e of e. So just like my base is canceled out over here with the log, my base is canceled out there with the log. And we are left with x over 2. So that just gives us some of those simplifying properties that we can use to make those log expressions a little bit easier. And folks, that concludes what we're going to be doing with Lesson D. This would have been our next portion of the notes, which again, we've cut out due to the pandemic. So just a quick note, this just goes into what I briefly talked about, I think it was a couple videos ago, that exponential graphs have a horizontal asymptote and logarithmic graphs have a vertical asymptote. So this just gets into kind of our parent functions in a little bit more detail. You see we only have one parent point versus the normal 3 that we'd have in the parent table. And logs and exponentials are inverses of each other. So the x and the y values flip around. So just some interesting properties with the graph, or review of transformation rules, but this won't be anything that you are assessed on or have any homework on. So that concludes Lesson D.